Hello, everyone, and thank you for coming today to our January 12th Lunch and Learn. We will be going over the 45L 179D tax availabilities. We will have Mitch Richardson, Troy Pressler, and Pat be speaking today. We open any questions that you guys have during the presentation. We do have a mic that if you are comfortable, we would love to have you speak into for the presentation. We would like to thank Rocky Mountain Power, Dominion Energy, and the Office of Energy Development for being able to provide these classes for free for everyone today and to be able to live stream it to you guys on YouTube. Thank you very much, and we'll get Mitch to come help us today.
Excellent, thank you. Where is the PowerPoint? Right there. All right, so I'm Mitch Richardson. I'm the owner-operator and senior analyst for Building Science West. We do energy testing, modeling, rebates, tax incentives, this sort of stuff. Today we're going to be talking about the 179D, the 45L, and we've got a CPA, one of our CPA buddies here to come and tie it all up for us, because that's important when it comes to tax incentives. That's the number one tip I'm going to give you guys is always use a CPA when you're managing these two tax incentives. So the 179D has been around since about 2006. This summer it got updated significantly, and we're going to go over that. One of the most noteworthy things about the update is that it is now up to $5 a square foot. Before it was up to $1.80, up to $5. That's a big change. Wanted to thank UtahEnergyCode.com, which helps provide these services, and they have a lot of the documents and things that you'd need to manage some of these issues, such as this one. Also wanted to thank our sponsors today. So it's up to $5 per square foot for commercial properties. It's an accelerated tax deduction, and so that you can take it all in 1 year, which is, has obvious advantages rather than spread it out over several years. What types of buildings qualify for this? With the new update, they break it into two major groups. There's the tax-exempt buildings. So for buildings that are owned by outfits that do not pay taxes, that benefit is assignable to the designer of the building. So that would be your architect, your engineer, potentially, someone like us could do it if someone else verified the work for us. But that's an assignable benefit when the owners of the building do not pay taxes. The other big group, obviously, is the commercial buildings. The tax-paying entity or owner will receive a tax deduction up to $5 a square foot, and it starts at $2.50 a square foot. What kind of buildings qualify? The two big groups, new construction and retrofits. So new construction. First step is get an energy analyst involved, someone like us. I'll also give you some tips on how to find other people like us, especially if you're out of state. So get your energy analyst involved at the beginning of the building design and get an energy model built. Then you have to beat the baseline by 25%. Baseline is basically, we take the footprint and window sizes and all that of a building, then we specify that with code minimum requirements, and we determine how much energy that would use with those base requirements. Then we take that same footprint, same measurements, only we upgrade all the components with better furnaces, better windows, more insulation, and then we determine how much energy that saved, and that's how you get to 25%, 50%. Retrofit improvements. Instead of comparing against a modeled baseline, you're comparing against the actual previous performance of that building. And then you need to at least beat that previous performance by 25% to start getting these incentives. So the modeled baseline is where it's compared to the ASHRAE 90.1, which version can depend and is currently a little bit complicated. The Treasury, the IRS, the Department of Energy is going to determine a rolling schedule to be that you compare against. The intent is that the subject building will be compared against the ASHRAE version that was in effect 4 years previous to the building being put into service. But that has not been figured out yet. It is still being codified by the Treasury, IRS, and the Department of Energy. So until that is determined, the baseline is the 2007 version. It's not anticipated that that'll stick around very long because comparing against 2007 version right now is considered excessively generous. So we'll see how long that lasts. One of the important updates to the new 179D is that the number of eligible tax-exempt buildings and organizations has significantly increased. Whereas before you actually had to run down a flow chart to determine who was eligible a little bit. Now it's just pretty much anybody. Charitable organizations, churches and religious organizations, private schools and universities, private foundations. For example, churches and religious organizations. If you were the designer for one of these new temples that they're building here in town, and you talked them into building that so that it saves 25 to 50% of energy, then the designer of that building would be, the church could assign that benefit to the designer. Private schools and universities, same deal. Private foundations, political organizations, other nonprofits, Native American tribal governments, and Alaska Native corporations, all eligible. Though all those are available to assign that benefit to one of the designers. So if you know any architects that you work with, you might want to, and they don't know about this, you might want to turn them on to the idea. Commercial building considerations. First is that buildings over 50,000 square feet, you really want to get someone to look at that building. Buildings of that size are a little bit easier to qualify. Just the economics and how much work it takes to do a smaller building versus a large building is not that big. So the amount of time we'd spend on a small 5,000 square foot unit is going to be not too much different than how much time we'd have to spend on a 50,000 square foot unit. So so obviously we can charge less per square foot for a larger building. Other considerations, larger centralized heating, cooling, and chillers are excellent and can be very cost effective, very efficient, but do require extra analysis before we can give a thumbs up that that's going to pay off. Lighting is typically very low-hanging fruit, very profitable way to take advantage of some of these this incentive. Previously, in the old 179D, where they broke it into 3 groups, they broke it into the envelope, the mechanicals, and the lighting, and most of the time, almost all the time, we could get someone to pass off at least the lighting portion of the credit, and that's not too different now either. Getting the full, another thing to consider is that even though I want you guys all to remember the $5 per square foot number, I also want you to just put on the back of your head that getting the full $5 per square foot may not always be cost effective. Reducing energy use by 50%, that's a big bite. But when you're getting an energy analyst involved, we can help you figure this out before any expenses are made, before any investments have been made, so that you can have assurance that you will get your incentive for what you invested into it. Generally, more time in the design phase, more time that we have some the energy analyst, the architect, the owner has, the more time we have to do some back and forth generally, the more money we're able to find for these buildings. So what's my point is that get us involved sooner rather than later. Sometimes, like if we can still get involved once sticks start going in the air, too far past that, it's usually too late. But please, the sooner the better if you want to maximize your incentives. So let's talk a little bit about some of the technical details you need to get to reduce that energy. As mentioned, the 179D breaks performance into 3 sections. They break it into the envelope, into the HVAC and hot water, and then they break it into lighting. For the envelope is just the part of the building that contains the air and holds the insulation. So your walls, your ceiling, your slab, your windows. Typically so you should count on having to do a little bit better on all of those. Definitely above code you'll have to hit. You'll have to increase the insulation in the walls, the slab, the attic. Not necessarily all of those. It's something that we can help you figure out in the computer model. You could count on probably having to do a better U value for the windows that you're going to specify for that building. With either more panes or a better gas fill or a better framing material or better thermal breaks in the framing material. The third part of this is increased air sealing. We spend a lot of money heating and cooling air, and if that air just leaks right out of the building, then that's an immediate loss. So if we can prevent that air from getting out, then that helps. Then that's an immediate savings. So those are the 3 things that we talk about when we go for envelopes. Again, the bottom line is it's all going to need to be above code, or at least a significant portion of it. The second group, the HVAC and the hot water heating. On hot water heaters, the rating is typically the EF factor or the MUF. I can't remember the new rating for it. UEF. The UEF or the EF is the rating for water heaters these days. I would not specify anything less than a 0.68 to start, and you might have to go up from there. On gas furnaces, I would not specify anything lower than a 95% efficient gas furnace. On compressors, I would not specify anything less than a 14 SEER. That's a little bit easier right now as starting this year in North America, all air conditioning compressors are supposed to be 14 SEER or better. So once we run through our supply of old 13 SEERs, those will be exhausted and all you'll have available is 14 SEERs. I would not specify anything less than a 14 SEER. Again, you'll probably need to be above this in several areas, but that comes in the detailed model later. If you're doing heat pumps, if this is going to be an all-electric building, I would not specify anything less than an 8.5 HSPF. For lighting, at minimum, specify LEDs. That's pretty simple, pretty doable these days. The other part that gets ignored or forgotten about a lot is lighting controls. I'm sure you guys have all seen pictures or videos of big cities at night where no one's working in those buildings, but like easy 30% of the lights in the skyscrapers and other buildings are on, even though there's no one in there working, no one there taking advantage of that light. So lighting controls is a very effective way to reduce lighting usage in a building with occupancy sensors, timers, that sort of thing. So between LED and those occupancy controls, that's a big chunk of where you need to go. I get pushback when we're talking about lighting a lot of the time, where people will say, well, yeah, but I don't want my offices to be dim, and I don't want to have everyone use a lot of desk lights to get the right amount of light in the building. And this has been very much addressed in the standard. There's a minimum lumen per square foot and a maximum lumen per square foot. And they're very generous. It's a very generous range. So you won't have to work or lease out a dim office. That's not something you'll need to worry about. So once you've got the building specified, modeled, all figured out, it's out for bid. We built it, we inspected it. How do you claim the deductions after it's all done? Well, number one, as I have mentioned and will continue to mention, first, use a CPA with experience in the 179D. Use a CPA with experience in cost segregation, because that's the best way to take maximum advantage of this style tax benefit. Once it's all figured out with your CPA, they use a super boring form, 3115, and you're done. If, let's see, timing, yes, okay. So timing, you can go backwards up to 3 years if you're willing to file an amended return. Again, see your CPA, and our man Pat here is going to probably touch on that a little bit. Tax incentives can be carried forward for future years if you plan for it. If you've sat down with your CPA and you figured out a way to make that happen for you, you can. So you can say like, we're not going to be able to use it this year because 2003 is going to be awful. But if you set it up right, you can have it carry forward for future years in certain ways. Are you planning a new commercial project? Get this stuff in front of an energy analyst to build an energy model to see how much of that $5 per square foot will be cost effective for you to pursue. Please do it in the planning stages. And again, like we have been able to pull this off all the way up to sticks in the air, frames with framing done, and we still have been able to help people out and get some of these things, but we can't always do that. So please get us involved, the sooner the better, or someone like us. How much money is available? So the maximum amount is, so the minimum amount is 50 cents per square foot for a 25% improvement against baseline model. It increases $1 per square foot all the way up to a 50% improvement. Very important bonus deduction is that if you meet the prevailing wage and apprenticeship requirements, you get the bonus deduction starts at $2.50 a square foot rather than 50 cents a square foot, and goes up to that full $5 a square foot. The prevailing wage and apprenticeship requirements are anticipated to be much easier going than the Department of Labor prevailing wage requirement, documentation requirements. Again, this hasn't been completely settled yet, so we don't have the guidance from the IRS, the proper IRS committees on quite how to administrate this just yet, but it is anticipated that meeting prevailing wage for this purpose will be much easier than the Department of Labor for two reasons. One is they just don't want it to be that onerous, and second is a reason that just escaped my head. I'll come back to that. So let's see. Let's look at the chart there. So if you have improved over the baseline, or if you have improved over the previous performance of the building, if you've made a 25% improvement, you get 50 cents to $2.50. And it goes up from there. So it's no longer just a either or, yes or no. Now it's like a sliding scale, and you can go all the way up to that gorgeous $5 a square foot. Efficiency breakdown, as mentioned, 179D has 3 sections that will need to be addressed in order to maximize your return on this incentive. You got to improve the envelope, which is what holds the air and the insulation. You got to improve the HVAC and the hot water, and you got to save money on lighting. What does analysis and testing entail? And if you guys have any questions as I'm jabbering, feel free to jump in. Yeah.
What's the going rate for an energy model to be created? Is it based off of square footage, or how's that calculated?
That's a great question. So before the middle of summer, it would cost 10 cents a square foot for us to do our work to build the energy model. But now with the new report, it'll be more than that. It'll be 15, 20 cents a square foot. Yeah. The computer model. Computer model is the first most important step in determining how much performance we're going to get out of the building and the specifications specified. We use the eQuest software that is run by the Department of Energy. What we do is we build a virtual model of the building. Again, we measure out all the walls, windows, etc. Build it just like you would in a CAD program. And then we add, values for like how much insulation is in each of those components. The software does all of its calculations to determine what kind of performance is going to happen. We do it, the baseline. All the components are spelled out at code minimum, and then with the improved specifications, obviously we'll use less energy than that, and then that difference is what you get paid on. After the model's been done, after the inspections have been done, the last thing we do is we do an on-site visit to verify the lighting density requirements with photometers. Then we issue a final report, which you keep on file. Then you use Form 3115 to claim that deduction, and please use a CPA. So local help. We've got a representative from Haney & Co. here. They're a big outfit here in town. They do great work that we've been working with for years. We've also done a lot of work with WSRP, another CPA firm that have done this kind of stuff. They also do great work. For energy analysis, obviously you can go to Building Science West, us, to help you with this. Another outfit in town is Nexant. They do modeling analysis. They are more expensive. They don't do as much testing and inspections, but they are also available. For non-local help, I would just jump on Google and search for 179D Tax Advisor, and you'll find probably 6 or 7 outfits that'll have big web pages set up with information about it, and they can help you do this stuff as well. Yes.
You said this was available for existing buildings as well. When you're doing that, what is used as the baseline? Is it just where that building's at now, so it's a test in, test out, or is it code when it was built, or current code? Or?
So yeah, it's a test in, test out situation. So it's so we just like. Let's say we were going to upgrade this building we're in right now in 2023. We would compare the performance of this. We would gather how this building performed in 2022, and then we'd plug that into our models, and then we'd model an improvement in. We'd model the improvement to that, and we'd have to beat it by 25% or more.
Okay.
Yeah. Yeah. Sure.
Do you have a sense for how much better the DCFM standard is to the 2007 ASHRAE 90.1 right now? Is it 25% already better for the DCFM standard?
I don't know. You don't know either? Okay. I don't know how it would quite compare. And plus it's tricky because, as I mentioned, they're going to have it on a sliding scale where they compare you to the ASHRAE from 4 years ago. So if the year the building went into service, we're supposed to compare the baseline for that building is what the ASHRAE was 4 years ago from that. And so, like, I don't know quite how to compare that to that other standard. Yeah. But, in a detailed analysis, if we were talking about an actual building, I could figure that out for you. So if you are interested in this, or you feel like an architect you're working with or a builder you're working with would be interested in this, what do you do? First, when you're pitching this idea, I want you to remember that it's not entirely free money. You are going to have to increase, specifications, and that's never free. But start making, just in general, you're just going to have to start making above code specification choices. Second is contact an energy analyst, a HERS rater, an energy engineering firm, et cetera, the people I told you to Google, and get them modeling your building. After the analysis is done and the specs are picked, or rather I didn't state that very well. Please get your analysis and specifications figured out before you send everything out for bid. One when the analysis and the specs are picked after everything's gone out for bid, that's always so much work. Because someone will always forget, someone will always value engineer something away. It just all goes smoother if you do it from day one. And if you're doing it from day 10, just keep in mind, please talk to your supers, your purchasing agents, and tell them not to value engineer, not to delete anything in regards to energy performance without talking to the energy analyst first. This happens probably twice a year where we'll show up on site and we're like, hey, where's your widget? Where's your energy efficiency widget that you said you were going to install? And they're like, oh, I don't know. And then they'll ask around and somebody in the office, value engineered it away. And then we've all got to scramble and it's more expensive to put that back in. So when it comes to energy stuff, if you've got energy related goals, please talk to your energy analyst before you change anything. Last point on what to do. If there's two things that I want you all to remember, it's that potential for $5 a square foot and to call an energy analyst. And then everything else is just an asterisk that will hold your hand and help you guys figure it out. Again, thanks to Dominion Energy, Rocky Mountain Power, and the Utah Office of Energy Development for putting on these things and helping us to educate you guys. And there is my contact information. Again, $5 a square foot, and call an energy analyst. That's the way to succeed. Any other questions before I turn it over to Pat? Okay. You want to help there?
Oh. Sorry, give me 2 seconds. Where did it go?
Perfect.
It's not sharing on the screen. Hold on 1 second.
All right, you're good. Take your time.
Sorry, technical difficulties. Just give me 1 second, please. There we go. Thank you, Pat.
Thank you. I appreciate the opportunity to be here. We've worked with Mitch on numerous projects. Kind of add on to the reputation Mitch has. When we first got into 45L, we did a pretty large, substantial tax credit that we carried back numerous years. And I think it's one of the first ones the IRS saw that kind of like, whoa, that's a large tax credit. We better audit that. And so with Mitch's work, we were able to get a no change on that substantial tax credit. And the client was ecstatic because it was that large of a tax credit that we took advantage of. So I want to not necessarily bore you to death. I am an accountant. It's not worse than an engineer. I have worked with plenty of engineers, and I think I'm a little more charismatic than some I've met with. But if you go on a trip with us to a building, we're a pretty dull and boring bunch to be with. So I want to talk about the 45L, the 179D, and the creative way that we like to use cost segregations, and specifically in the 179D deduction. Because I want to talk a little bit about the 179D deduction. It's not an added deduction, right? It's not a deduction that we're taking from thin air, right? The deduction comes from the basis of the property. So for example, you have a $5 million commercial property. right? And there's a 179D deduction that you can accelerate that Mitch discussed. It's $5 a square foot. You can take that all in the first year. Where is that deduction coming from? Well, it's coming from the basis or the price of that property. So that $5 million deduction, we can get that $5 million basis of the project, we can get $1 million deduction in that first year, okay? That $1 million comes from that $5 million. So that $5 million now becomes $4 million that we're gonna take over 39 years. In my second life, I'm going to be a finance major because I love present value of money. And if you do the present value of the dollar, you talk to anyone writing the checks to the IRS, we want to accelerate every stinking deduction we possibly can and defer our taxes down the road as much as we possibly can. And that's what we're doing with 179D. 45L is different, and I'll touch on that a little more different because that's a credit, and credits are different than deductions. But in doing a 179D deduction, there's two parts of the tax code I'm going to bore you with, very high level. I'm getting ahead of myself. These are supposed to keep me, I have 9 kids, so I'm always changing subjects. So this is supposed to help me stay on course. Oh, thanks, Mitch. I'm used to just being behind a desk, so. Is the space bar just supposed to get it going? Arrow? I'm used to a Mac as well. Sorry.
Okay, there we go.
Okay.
So if you can,
Go back.
there you go. I just hit enter.
Okay. So the objectives, again, I got really ahead of myself. What are the Inflation Reduction Act energy incentives? In 2021, 179D was finally permanently placed in the law. What happens usually with tax code is the Congress likes to work retro, and so it's hard to plan. We're always working a year behind. But in 2021, they finally said, okay, the 179D is going to be permanent. And they also did the same thing with the 45L, not necessarily permanent, but they're going to extend it for an additional 10 years, which is incredible because since 2005, when this was all enacted, we were always having to work retro. Are they going to pass this or are they not going to pass it? And it was really hard to do tax planning with clients and specifically planning on the engineering side on what to do going forward. I want to discuss what the benefits and the incentives, identify opportunities, and kind of the process in the accounting world. Now, Mitch has to put together a report that not necessarily we have to turn in to the IRS, but we do have to report it on the tax returns. And if they are audited, which they have been, we always have to refer to the work that Mitch has done for us. And if you have any questions, raise your hand. I'd be more than happy to help you out. Okay, kind of already discussed this. The 179D deduction was made permanent in the CAA Act in 2021. And the Inflation Reduction Act significantly changes the deduction amounts that Mitch discussed. It went from $1.88, that was with inflation, to up to $5 a square foot, which is quite substantial in your, when you plan for if these credits are good for what you're building. So I want to talk about the credit versus deduction. Man, I'm struggling here. Well, it's not coming up. That's okay. So tax credits are dollar for dollar credit. Whereas a deduction, it's based on your effective tax rate. So to kind of simplify that, the 45L prior to 2023 was $2,000 tax credit. So what that means is if you have, at the end of the year, $5,000 tax payment to the IRS, but you qualified for the 45L for $2,000, you only have to pay a net $3,000 to the IRS, okay? Now a deduction is based on your effective tax rate. So with the 179D, you have a $10,000 accelerated deduction, but your effective tax rate is 20%. So that $10,000 deduction is only going to be worth $2,000 in tax savings. So credits are always a lot better than deductions. But if we can take those deductions up front, which we want to do with the 179D and the cost segregation, we'll definitely do that as well. Does that make sense? I can't get these to pull, and I apologize.
Is it changing on your screen?
Yeah.
Or is Steven Standard?
Yes, that's good. Oh, you're good.
You're fine, I'm sorry.
No, you're
I don't
good.
know what's going on.
Oh, you're good.
No, just added slides, that's not what I wanted. I apologize, everybody.
I'll just keep going on. You're totally fine.
Okay, sorry.
No, you're good. This will just be for me, so I can stay on track.
I can share the slides afterwards as well. If you guys want to see the slides, I can email them to you, so that you can have those that information.
So I'm sure you're well aware of the IRS is slow in coming out with standards. Like Mitch alluded to, they haven't come out with a standard yet. They hope it's 2007. It might be different. And the same kind of goes for their audit technique guide. So basically when a statute comes out, the IRS comes out with an audit technique guide that allows you as a preparer to see what the IRS is looking for if it's ever audited. And it's going to be out in May. So for those who want the returns done quickly and you have a 45L or 179D, I would suggest extending so we make sure that we are covering all of our bases in regards to the audit technique guide. And again, they said it would be out in May, but we'll see. So the 179D, what's interesting with the 179D is there's not a specific form on the tax return that requires the information input. So if you have a commercial building, there's a part on the tax form that says other deduction, and you specify in there 179D. Now to me, that means it's a pretty vague, ambiguous deduction, and it's hard for anyone to go another deduction and see what the heck that is. So it's important that you have Mitch's work to substantiate that deduction, okay? So what I'm saying is $5 is a lot per square foot, and it's important that you have Mitch's testing to substantiate that deduction. Otherwise, the IRS will say, hey, what's this $3 million deduction? Yeah, I don't know. So it's important to have that information on hand. Now the question is, what on earth does a cost segregation do with a 179D deduction? I'm going to talk about two tax codes, 1245 and 1250. 1245 property is what they call furniture, fixtures, anything that is not permanently affixed to a building is considered 1245 property. 1250 property is permanent property. So your shell of the building would be considered 1250 property, land would be considered 1250 property, and land improvements would be considered 1250 property. Now, why is this important? Well, because 1250 property is assigned a 27.5-year life or a 39-year life deduction over the life of the building. So I gave you the example that $4 million, it's going to get a deduction of over 40 years, $100,000, okay? Well, in 40 years, that $100,000 is going to be worth like $50 the way inflation's going, right? So what a cost segregation does is we go through the building, just like Mitch is going through to make sure it's energy efficient. Well, we go through the building to make sure that we want to componentize what they call 1245 property. To give you an idea, this room right here on a depreciation schedule would be $200,000 over 39 years. Well, I'm going to go through this room and I'm going to say, hey, this carpet is 1245 property. It's not permanently affixed to the building. I'm going to take it out. I'm going to either assign a price to it based on RS means or based on draws or RAI funding. The projector, the wiring to the projector, the chalkboard or the whiteboard, wiring to this. I mean, so there's so much in this room that's considered 1245 property that I'm going to take from that 1250 bucket and accelerate it. So that $100,000 of this room that we're taking a deduction for the next 39 years of $1,000 in 39 years will be worth maybe $1. Well, now I'm going to take $30,000 of that up front because I've allocated it 1245 property. Does that make sense? So when we do a 179D study, we have to take the basis of that 179D. So $5 a square foot, this room is 20, to simplify things, it's 20 feet. 20 times 5 is 100 feet. So we have a $10,000 room, $100 tax deduction, 179D, we're going to accelerate that. But where are we taking that deduction from? We're taking it from that $10,000. So now we have a 1250, 1245 property, 179D deduction, but what am I allocating to that 1250 property? Am I making sense? Okay.
I think it makes sense that we definitely, anyone wants to get maximum amount of money, they need to talk to you.
Yes, yes. So basically, we do the 179D deduction last. We do the cost segregation first. Why is that? Because we're reducing our 1250 property when we do the cost segregation study. And therefore, in our 179D, we are maximizing even more that accelerated deduction because now we're taking it from a cost segregated study from 1250 property to 1245 property and including more reduction of that 1250 property from that 179D. It's in the tax code, but we do an analysis, we run all the numbers, and we show you where the savings is, how much we're going to save by doing it this way. So it's imperative, in my opinion, if you have a building that is a commercial building, not a non-for-profit, but a commercial building that you're doing a 179D with, it's imperative you do a cost segregation with it. And you will save exponentially more by doing them hand in hand. That make sense? Okay. I want to touch a little bit on the 45L. I know, and that's, go ahead.
I'm probably stepping on your line. Is the cost seg is important when you're working with the 45L as well?
Yes, for sure. So the 45L is going to be residential. 179D is commercial or non-for-profit, churches, hospitals. But 45L is going to be multifamily, residential condominiums, even in some assisted living facilities, they can be deemed as 27.5-year life buildings. So 45L, before IRA, which is the Inflation Reduction Act, it was up to $2,000 per dwelling that qualified. Now that IRA's passed, it's up to $5,000 per dwelling. So a lot of the multifamilies that you see, it adds up quickly. And that was one of the projects we worked with Mitch. It was a $2,000 credit per dwelling. He was one of the larger multifamily in the Mountain West. And so it adds up quickly if they've paid taxes. And I guarantee you before 2022, I guarantee they were paying taxes. And so what you can do with the tax credit is you can actually amend the returns that you're paying taxes on and get refunds. And that's what we did with the client that Mitch and I worked on. So the 45L is a tax credit. That's what makes this, in accounting terms, more sexy than a deduction. because now we're getting dollar for dollar a credit on what we're paying in taxes and not a percentage of what we're paying in taxes. So if there's any residential, even multifamily building owners or 10-plex, it makes sense to do it. I don't know cost-wise, Mitch, if it makes sense to do like a 10-plex, but it does. There you go. It makes sense, for sure. So the cost segregation, the reason why it makes so much more sense is the cost segregation will also, it's a deduction, but we're accelerating that 1245 property all up front, and now you're getting a tax credit. So you're getting the best of both worlds. You're getting a deduction that you can take and carry forward, because guarantee you if we're doing a 45L and a cost segregation, we're not paying tax in this year. But we probably paid tax in the prior year, so we're going to take that credit dollar for dollar and take it back. And that deduction we're taking today, we can carry forward. So if you're in multifamily, I'm sure you either are going to start doing cost segregations or have already done them, because a lot of times you're not paying tax forever. You're just kicking that can down the road as far as you possibly can until you do like a 1031 exchange and put it into a trust and then give it to your kids who get a step up in basis. That's the tax strategy there. Boy, any questions? Awesome. So the only difference between the 45L and the 179D on the tax return is we have to fill out the 8908 on the tax return for the 45L. And that's specific to energy credits. So the IRS is seeing, hey, they're taking the 45L, red flag, not necessarily red flag, but hey, let's check it out. And that's what but brought up that huge credit that Mitch and our firm worked on. It was the largest 8908 that had been filed. I think it was like 2006 we filed it. It was
Like $500,000.
Yeah, and it was way early, and they had never seen a refund that large from a 45L. And so it was on the 8908, we file it. And it's important that you have a CPA fill it out correctly, because if it's not filled out correctly, they will not issue the refund, period. It has to be done correctly. That's the same that goes with the 3115. And so if you do a cost segregation, you have to fill out the form 3115. And Mitch says it's boring. It is. It's like 18 pages long. It's a change in accounting. And so you're telling the IRS we're changing from impermissible to permissible depreciation. And it's an automatic positive ruling, but you have to send it to a specific place to the IRS that they have to check mark and say, okay, they're making a change in accounting. I work for a heating company. I've been there for 16 years, and that's all I do is cost segregations, 179D, 45Ls, solar credits, anything that's energy efficient or tax saving strategy along that line is what I mess with and deal in. And we've used Mitch all the time, and we love his work and what he's done. So, any questions? Jokes? Okay, we're good.
Thank you very much, everybody. We're going to take a short break for lunch, and we will be back in about 30 minutes to hear Troy on the 45L. Thank you.
Hello, everybody. My name's Troy Pressler, and I'll be talking about 45Ls and Energy Star certification. So just want to get started off with saying thank you to the sponsors of this program, Dominion Energy, Rocky Mountain Power, and the Office of Energy Development from the state of Utah. And also note that part of the Utah Energy Codes program is a wonderful website, utahenergycode.com. It's singular. If you go plural, it's a different website. And it's a great resource. I go there quite often. The code that we're using in Utah right now is an amended version of IECC 2015. And so sometimes if you went and bought a book of IECC 2015, you might not know specifically what the amendments are that the state of Utah has had in place for some time. This website has that information up there. It shows the amendments that have been in place since, I think it's been 2015, 2016, something like that. Mitch also mentioned HERS raters, energy analysts. There is a list of HERS raters up on this website as well that are, it's exclusive to the state of Utah, but, and if there's any HERS raters out there listening who have checked the website and they're not up there, please reach out to Resource Innovations and they'll be able to get you listed on there so that we've got a picture of all the HERS raters that are working in Utah at the time. Yeah, and this is a screenshot of the website, utahenergycode.com. So, 45L eligibility. We've talked about 45Ls earlier, and I just want to take a step back. My understanding of the history of 45Ls, it started around 2006. And as Pat mentioned, Congress renewed it pretty much year to year from 2006 until 2022. Sometimes it was renewed at the end of the year to go retroactive. So like November of that year, they would say, oh, we're going to do it again for the previous year. And so, again, difficult to plan if you're a builder, if you want to try and reach that standard, not knowing if it's going to be renewed. That was never a guarantee. And the standard that was required for 45L eligibility from 2006 through 2022, I'll just call it a proprietary energy efficiency standard. When we do energy modeling, you put all the inputs into the software, and then there are a number of reports you can run out of that. And basically, as I'm thinking about my computer screen, over on the right side, there's a list of qualifications, and as that house has been built in the software, you can click on it and say, oh, is this house eligible for this code? And it'll have, you know, a green check or a red X. Is this house eligible for Energy Star or other things? Well, one of those check boxes is 45L, and so it's been maybe a little nebulous as to what qualified for 45L in the past. You kind of had to model it and then just see if it passed or not. And certainly through the years, you know, we've been able to give a laundry list of people and say, look, if you do these 4 things, you're in the ballpark and you'll probably get it. But it's not like we've really had some established, published, well-known set of criteria that would make you eligible for a 45L. Again, it was a federal government proprietary level of efficiency. And it wasn't based on nothing. It was X% more efficient than 2006 code. But it's hard to understand what that really means unless you've got energy modeling software. So, and I'm sure everyone does that on the weekends just for fun. So, 2006 to 2022, 45L eligibility was limited to structures that are 3 stories or fewer, and it was, as Pat mentioned, a $2,000 per unit federal tax credit. So last summer, the Inflation Reduction Act changed 45Ls, and probably the most exciting thing about it, as Pat mentioned, it extended it out for a 10-year period. So now we can plan on eligibility or availability of the 45L for the next decade, which makes planning much easier going forward. And the requirement for the 45L changed as well. Instead of being, we'll say, a percentage more efficient than 2006 code, now it is Energy Star for new homes. That is the requirement. If you reach that certification, then that dwelling unit is eligible for the 45L tax credit. Right now in Utah, we are on Energy Star version 3.1, revision 11. Now, the version of Energy Star, when you go from 3.1 to 3.2, or I imagine there'll be a 3.3 someday, I don't know. Those are typically increases in efficiency requirements. The revisions going from revision 11 to revision 12, that typically is just adding clarification in language or requirement. It's not necessarily going to anything more restrictive or more difficult. It's just the EPA has received feedback for X number of years or questions, and they say, well, if we've received this same question 500 times, maybe we need to maybe clarify a statement or make a change. So I don't see revision 12 being anything earth-shaking. Especially, I mean, there were big changes from revision 0 to revision 1, but now that we're this far down the path, things are pretty solid. There's nothing in the Energy Star timeline that would move the state of Utah to version 3.2. Energy Star requirements are state-specific, depending on the energy code of that state, and some states are at a version 3.2. Utah's not there, and it's not currently on the timeline since I checked this morning. The 45L has gone from $2,000 to $2,500 per unit. There is, in multifamily situations, you do have to show prevailing wages were met to be eligible for that $2,500. What that means, Mitch touched on this, we're still a little squishy as to what prevailing wages is going to mean, but if you don't show that, it's at $500. My suspicion is that won't be a difficult thing to show. But again, once the government lets us know, we'll all have a better understanding. It's just not known yet. Okay, so let's go back to Energy Star, because that is the requirement for the 45L. So that's what I really want to spend the bulk of my time on, is Energy Star requirements. Energy Star for new homes has been around for, oh my goodness, probably 20 years now or so. It's been the basis of rebate programs from both Rocky Mountain Power and Dominion Energy in the past. It isn't currently, and it has gone through a number of revisions. And this is the way I understand it, or the way I like to teach it, is that there are two main categories of requirements for Energy Star. And the reason I think they've done this is when you make a home more energy efficient by doing two things, adding insulation and reducing air leakage, you also make that same home less tolerant of water. So I live in an old home. It turns 140 this year. I literally have, in parts of it, hollow walls. They're full 2x4 walls, but I've got wood clapboard siding, tar paper, a 4-inch gap, and lath and plaster. Those are my walls. So if that wall gets wet, it's going to dry very easily because there's nothing to hold that water in place, and there's plenty of air moving through it. So from an energy efficiency standpoint, not good. From a durability standpoint, just great. Wood won't rot as long as it's able to dry completely between the times it gets wet. So one extreme, you have my house. Well, with Energy Star, what we've done is we're asking people to put in more insulation, install it better, and then we're asking you to air seal the homes better, which is great. That really helps you with the energy efficiency of the home. What it also does, though, is it makes it so if that house, if some of the wall or roof assemblies get wet in that house, they don't have as easy a time drying as my old house does. So, so what a lot of Energy Star does is says, we're going to make your home more efficient, and we're going to put some checklists in to help mitigate the potential drying problems of a more energy efficient home. So I say we've got two categories of requirements: efficiency and mandatory checklists. And I see a lot of these mandatory checklists as just trying to address the potential problems that exist in having an efficient home. Okay, so from the beginning, Energy Star has been designed to be ballpark 15% more efficient than current code. And that's why there are different versions of Energy Star out there for different states, because the code requirements vary state by state. And when, I think it was just last year, we just barely moved from 3.0 to 3.1 in Utah just about a year or so ago. So they just upped the requirements a little bit quite recently. And also the energy efficiency threshold is also dependent on, to be simple, just the bedroom to square footage ratio. And really the thinking in this was, and I used to know the Sam Rashkin, the guy who was the godfather of Energy Star New Homes. And what he said was, I hate the idea of having some massive McMansion with an Energy Star label on it, because that home should be half the size. And so what they did was, there is a ratio of bedrooms to square feet. And if, my example here, if you've got a 10,000 square foot home with 2 bedrooms in it, they're going to require that home to be more efficient than a 2,500 square foot home with 2 bedrooms. Now, if it's a 10,000 square foot home with 10 bedrooms, like you might need if you've got 9 children, then that's okay. But what they don't want is for luxurious estate homes to be claiming to be Energy Star just as easy or easier than smaller, more efficient, effective homes. Okay, so Energy Star efficiency requirements. I made up the word trade-offable. It's copyrighted. Every time you say it, you have to pay me. So what that simply means is that really the items on this list is a standard that you will be held to. And if you don't meet that standard, it's not an automatic fail. But what it does mean is that you're going to have to do better in some other part of this list. And again, the items from this list, they go into a software program. So, it kicks out a level of efficiency. Typically, what's called a HERS score, a single number representing the efficiency of that home in comparison to a reference home. So, if you're hitting these items pretty close to it, you're probably in the ballpark of the efficiency needed. Now, what I think is interesting here is that the insulation levels for Energy Star, as it lists here, is IECC 2012 standards. Utah is actually at IECC 2015 with our insulation levels. So, according to Energy Star anyway, we're kind of getting where we need to be with insulation levels. Same with air infiltration, 3 air changes per hour. That's actually the same as IECC 2015. So there are plenty of builders that we work with that are really at this level or better even before they were doing Energy Star. I think these efficiency standards are, I'd call a sweet spot between cost and benefit. One thing to note is all ducts and air handlers in conditioned space. That's not required for Energy Star, but there is an energy penalty for having your ducts and or equipment in unconditioned space. So if you do have a duct system in an unconditioned attic or an entire HVAC system, know that even though that's allowed, you're going to have to do something else to make up for that that energy penalty by putting your. And I know that there are reasons people do it. If maybe there were one thing I could add to code, that might be it. Don't let systems be in attics. And the HVAC contractor in the room nods with his approval. Okay. Okay. And as with Mitch and Pat, if anyone has any questions, let me know. Okay, so we touched on efficiency, which I typically see as, you know, your heating, cooling, water heating, insulation, windows, air sealing, just those levels of efficiency. Now there are mandatory checklists. You probably can't see it from there, but what this checklist says in the bottom corner is 1 of 7. And that's not 1 of 7 checklists, that's 1 of 7 pages for this one checklist. So when a builder calls me and says, okay, so what do I have to do for Energy Star? Well, how much time do you have to talk? Because it is not, it's not something that you can really cover in detail in 10 minutes. Literally, this is the page 1 of 7 pages of, this is the Raider field checklist. This is the checklist that we fill out. Okay, so here are the checklist. HVAC commissioning checklist, and that is going to be completed by whomever is commissioning the HVAC system. I would say typically, and feel free to nod otherwise if you disagree, Ryan, in residential new construction, the same company designs, installs, and commissions a system. Yes, okay. So the commissioning checklist is going to be filled out by your HVAC contractor. HVAC design report, also the contractor. National Raider design checklist, that's the HERS Raider, whoever you're working with there. National Raider field checklist, again the HERS Raider, and the water management checklist. That one is actually filled out by the builder. And these checklists have to be all kept and filed away. We don't require that they all get turned in for every home, but they have to be available for audits. HERS Raiders, the industry, HERS Raiders have, we'll say auditors that we work under called HERS providers, and then they get audited as well by an organization called ResNet. And so everyone has people auditing them to make sure that things are being done correctly. And so that's where these checklists come into play, is when an audit is needed. Okay, HVAC commissioning checklist. Do you see who's on there, Mitch? Yeah, one of our guys. So this is just, it's been a while ago. So this is just one of our guys doing a duct leakage test. And I just put it on there because it's more interesting than nothing but white. So the HVAC commissioning checklist is really, it's really just ensuring that the HVAC system is functioning as it was designed to function. In commercial buildings, commissioning is a big deal. And you'll hire a commissioning contractor to come in, and it's really involved. Typically, it's not that involved in a residential scenario, but it's just as important. I would say it's something that isn't always addressed the way it should be. And really what we're trying to ensure is that the refrigerant charge is correct, and that the static pressure in the system is correct, and that the airflow, and static pressure and airflow are related to each other, so that you're really making sure that as much air is supposed to be moving through each register is. And even though you're buying a brand new home, there's no guarantee that that is happening correctly. So really what this is asking people to do is just to make sure the HVAC system is functioning the way it was installed to function. Is that fair, Ryan? Is there anything you'd add to that?
90% of the systems are not functioning the way they're designed.
And word from Ryan, 90% of the systems are not functioning the way they're supposed to, and that sadly doesn't surprise me. So I'd say that's a good pitch for purchasing an Energy Star home. So the design report, there's but before an HVAC system can be installed in a house, it needs to be determined how large that system is, and you do that by doing heat loss calculations, and for some reason that is called a manual J. And so I know I've never understood why a heat loss calculation is called manual J. It is, and that determines. Do you know?
Yeah, guy that invented it is named Jack.
The man that invented it is named Jack. There we go. We all know now. And there's a manual D. The man that invented that was named Dave. No, no. So there are design programs. Manual J does the sizing. Manual D is the duct design. Manual S is the equipment selection. And doing these three things, having the plans and the specifications of the home allows an HVAC contractor or engineer to design the system. And an HVAC system, you've got several parts, and typically in residential new construction, the duct system is just on site, and oftentimes it's assembled to fit the space that's been allowed for it in the home, and maybe the home designer didn't do a good job of thinking about the HVAC system, and so maybe certain ducts are smaller than they should be, and then that causes problems, but we won't spend too much time on that. So what this design report does is it asks the HVAC contractor to show that they have done this correct design of the system, as well as the ventilation design. I put in this photograph that I took several years ago that I will tell you, I know what they were thinking when they did it. I just don't agree with what they were thinking, because that's probably a 100 CFM fan, and it is probably moving, I'm spitballing here, but 25 CFM because of the way that duct is installed. The fans in furnaces and ventilation fans, they're not designed to push very much pressure, and having that come out of the fan and right into a truss and having a hard corner significantly diminishes the amount of air it will move. And then putting that pretty much 180 degree, maybe a little more than 180 degree loop in it is the equivalent of probably 50 to 60 feet of straight pipe. So thinking of things like that are what these reports do. Now, the design report wouldn't necessarily help the installation unless they specified you need to have 18 inches of straight duct before there's any turn in it, typically, for a ventilation fan. And so why do we care? I always like to ask that question. Why do I care if my ventilation fan's working? Well, let's go back to the beginning. And what all these checklists are really trying to do is make the home tolerant of moisture. And boy, the best way to make it tolerant of moisture is to make sure that the water that is generated in the house is able to be vented out of the house. And in this bathroom, that's not going to happen. So it's going to have to be dealt with some other way now. Okay. The Raider Field checklist. So I've got a number of bullet points on here. Each one of those bullet points just represents a category of things that we inspect. And there might be as few as 2, but there might be 10 or 20 things that we inspect for in that category. I highlighted reduced thermal bridging because there's a solid wood wall installed in this home. And I was walking the home with the builder, and we rounded the corner and saw that, and he just buried his face in his palm. And like, these guys must think 2x4s are free. And the light switch for that door is, 2 feet away from it now instead of right next to it. And there was no structural reason to have, it is almost 2 feet. Maybe it's 18 inches of solid. This is a 2-story home. It's not like a part of a big multifamily thing. So that's one of many things that Energy Star addresses. Grade 1 insulation, what that means is that the insulation's installed correctly. You wouldn't think that we would need to do that. But Ryan said that 90% of HVAC systems don't function correctly. Mitch and myself and Jeff, who also inspects homes, how many homes have the insulation installed correctly? Probably less than the heating systems. I would say the only insulation that's installed well is blown-in insulation in walls, blown-in bibs. Fully aligned air barriers. Again, if we think back to the contrast of my 140-year-old house with hollow walls and how it doesn't have any problem drying out, versus these new homes that have thicker walls that are stuffed full of insulation and are air sealed. So we have fully aligned air barriers in the homes that are controlling where the air is able to travel and where it's not. Again, what we're trying to do is be deliberate with everything. Again, reduced thermal bridging. The great thing about reduced thermal bridging, most things with energy efficiency cost more up front and then save you money down the road, except for reduced thermal bridging. What we're asking you to do is use less wood in your house, and that saves you money up front, and then saves you money indefinitely. So it's the one thing that's a double save. I think that people put in additional studs. I don't know if they're scared the house is going to fall down or if it's insecurity. I don't know. The fun of the nail gun going off, maybe, because it is kind of fun. Sorry, Jeff, I know that's a touchy subject for you right now.
They were demoing a new gun.
Yeah, they're demoing a new gun. Yeah. And really what it looks at is doing, 2-stud corners, California corners, ladder blocking in walls when they intersect an exterior wall. In some cases, 24 on center framing, if you want to really go after it and save money on lumber. Yeah.
For some people, I'll say it this way. wood will let almost 3 times as much heat pass through itself than insulation.
Yes.
That might not be apparent.
Yeah. So that the white fiberglass there is, I believe this was a 2x4 wall, was my recollection, and that's either R11 or R13 insulation, and a 2x4 stud is roughly R3. So what we've done is we have tripled the heat conduction through that section of the wall by putting wood there instead of insulation. And I did a thermal inspection of a home yesterday, and when you hold the camera up, and all you're seeing is the surface temperature of the wall, but you can see where every stud is, and in many cases you can see all the screws that are holding the drywall to the studs, because that piece of wood is conducting the heat through the wall much faster, and then if you've got a 1.5 inch screw that's metal, that's conducting even more, so you can see those. So this is a big energy penalty. It's a double whammy because it costs more to do up front, and then it performs worse for the life of the building. So there's a list of specific reduced thermal bridging requirements, and that's one of the things that we come on site and inspect for. Oh, I think. Air sealing as well. Having air moving from inside the home, inside the living space, and making it into your walls and being able to travel behind the sheetrock is quite dangerous in the wintertime in Utah, because if that warmer, 70 whatever degree air that is inherently more humid than the outside air, it's being driven by I'll just keep it simple, by physics to equilibrium, and that's going to drive it to the outside of your wall, and when it reaches a cold surface, it's going to condense, and that's where you have problems. Water in vapor state is pretty harmless. Water, as soon as it condenses into liquid state, is quite dangerous for structures, and that's what we're trying to prevent, is through air sealing, is that water vapor making it really to the inside surface of your exterior sheathing. Again, not a problem in my old house because the walls are hollow, but in new homes, it is mold, mildew, rot, so it can be health issues as well. Again, it's Energy Star really trying to manage the risk associated with more efficient homes. Duct quality installation we look at. Here's, and I think I'll touch on this one again. This is a big one. Code does have a requirement for how leaky duct systems can be if they're outside of conditioned space. And in Utah, that typically means in an attic. Energy Star says that all duct systems need to be tested for duct leakage, whether they're in conditioned space or unconditioned space. And if your HVAC contractor is not used to having their systems tested and they're not used to sealing them, everyone fails the first time, and most second time, and some third. And it's really about how committed you are to getting it tight, and quite honestly, learning the best way to do it. So we do a duct leakage test on all duct systems for Energy Star, and there's a hard limit to the leakage. So I had a slide up before that had a number of things that I called trade-offable. Duct leakage is not trade-offable. If you are above the allowable limit, you either don't get Energy Star for that house, or if the ducts are accessible, you can get someone in there and try and do some sealing on the exterior of the duct system if they have been buried in the building so you can't get to them. There is an expensive option to seal them with a product called Aero Seal, which is a last-ditch effort, but that's what you have to do. So it's important. There's a water management requirements checklist. It does state on there that you can't have carpet within 2.5 feet of your toilet. So call your designers and make that change for your individual bathrooms. I had to put it in because I thought it's ridiculous that has to be in there, but it is. But on a more serious note, it asks the builder to do some really smart things. Smart like grade your landscaping away from the house. Things like that you would hope, again, you wouldn't have to tell people, and very specific things. Kick out flashings, really ways to manage all the water that's going to fall out of the sky on your house, so that you don't have problems with any of the roof assembly, the wall assemblies, your foundation getting wet. Because again, we built a house that is tight and full of great insulation. We need to make sure that we're able to keep those things dry. I can't remember if I missed. There were a couple things I missed on this. Mechanical ventilation, we also inspect for that. When you've got a tight home with lots of insulation, you do need to have an effective ventilation system. Energy Star doesn't just ask for you to have a functional one, but asks you to put in high-quality fans that actually move air rather than just make noise. Quite honestly, a lot of the fans that some builders put in that are just typically known on the job site as a $20 fart fan. It's ubiquitous term for it. They make plenty of noise. They don't move a lot of air, and you need to be able to vent the air out of bathrooms. Quite honestly, more so for the moisture that's introduced into the bathrooms when people are showering is probably the more important reason to have them in there. Filtration. There is also a specific level of filtration required for new homes. That's not a huge deal. It's really just the furnace filter that you've purchased and put into that system when the house is completed. Combustion appliances. We're also, when I say combustion appliances, I mean the furnace and the water heater, typically, assuming that they're gas. And we'll just go back once again. We're talking about a tight home, and so they really want to make sure that those combustion appliances are as safe as possible. So if you're using what is called an atmospherically vented appliance that draws its combustion air just from within the house, from the air that's in the house, rather than drawing it from through a pipe that's being drawn from outside the house, there are some very specific requirements that Energy Star says you have to have. Basically, you have to build an airtight room around your mechanical devices if you're using atmospherically vented combustion appliances. So it's all those things that we're looking for when we're on site and inspecting. Okay. Again, the water management checklist, that's filled out by the builder, and the reason for that is it really does require. It would require a HERS rater to be on site so many times that it would be cost prohibitive. We would have to charge ridiculous amounts of money if we had to do 10 inspections instead of 3 inspections. Plus, I think builders would be in a hurry to cover up some detail and not wanting to wait for an inspection. And so, again, these are handled by the builder, but they do need to be filled out and they need to be kept on file for an audit. So you cannot certify a home as Energy Star without a HERS rater. When the EPA started the Energy Star New Homes program, they partnered with a company called ResNet, and the job of ResNet would be to train and manage HERS raters. And so, yeah, it's just not something you can do on your own. Again, the UtahEnergyCode.com website has a list of HERS raters that are working in Utah right now. So typically what a HERS rater is going to do, at least on site, there'll be an insulation inspection. I mentioned that the insulation has to be installed properly, and it never is. So you have to go on site and inspect that, and oftentimes show them where there are problems and have them fix that. Duct leakage test, and we like to do that typically at four-way. The reason for that is the system's far more accessible at that time. So if there are problems, it's a lot easier for us to see where the problems are, and then a lot easier for those problems to be fixed. Again, if once the system's buried in the house, you kind of have one option, and that's the aero seal. And then at final, we do a blower door test, and that's what this photograph shows. This is it's a calibrated fan. I like to joke it's the smartest fan in the world. Might not be a lot of competition for that, but it is a fan that knows how much air is traveling through it. And so what we do is depressurize the home, and the little box that's hung there on the door, that is called a manometer. It's a very sensitive pressure gauge / computer built into one. And it's got a tube going to the outside and a tube in the house. And once you're able to induce a pressure differential from the inside to the outside of the house to an industry standard, and then that fan knows how much air is traveling through it, you're able to determine how much air is leaking into that house at that designated pressure. And this is actually a code requirement that all the homes get this test. Again, it's not universally enforced, but it is also a requirement for energy models and Energy Star. So that's what's going on here. That typically happens at final or close to final. Obviously, the house has to be pretty much done to know how much it's going to leak. Weather stripping has to be up, and finish, electrical, and plumbing. Typically, we like carpet to be in as well. So, similar to duct sealing, you might fail a time or two with your insulation contractor if they're doing the air sealing. Sometimes painting contractors will help out with that, with caulking in certain places. But everything's a learning curve. It's good to get the HERS rater in there early. We're always happy to go walk jobs with our builders at framing to show them where they're going to have trouble if they don't address it. And once you've done it 1,000 times, you know where it's going to happen, and help them determine the best air sealing strategy for that. So to hopefully minimize the trouble you have at the end.
Where do you often see the issues?
I mean, typically the single biggest problem in any home is a rim joist, and unfortunately, it's tough to seal it up unless you just go after it with spray foam. So typically, what we do is encourage what we call airtight drywall, which is using either seal or actually a product designed specifically for this called drywall gasket that allows you to seal the drywall to the top plates and bottom plates and around window frames. And what that does is it really, oftentimes you lose a lot of air going up into the attics are unsealed. And so if you're able to seal off between the drywall and the top plate so that nothing can get from the walls to the attic, you remove a lot of the driving forces. So, anything you want to add to that, Mitch? Yeah. Bonus rooms. Yeah, bonus rooms are fraught with peril when it comes to comfort and efficiency and air sealing and HVAC, and yeah, they're hardly ever done right, to be quite honest. So.
Who typically installs that gasket? Is it the
We don't like it when the drywall guy does it, because they either forget, they don't do it right, they cheat, or they ruin it themselves by not letting it cure a little bit before they slide the drywall up. So we like it when the insulator does it, and they, give it a day or at least a couple hours to cure it first.
Yeah,
So insulator typically.
yeah. And I guess I've got one builder his painting contractor does a lot of it, but usually it is the insulator. And the product is, if you look at it, it probably looks similar to great stuff, but you know how when great stuff is cured, it's really hard? This stuff is, when it's cured, it's very, very soft, so that it doesn't make it difficult for the drywall to lay against the framing. And it takes about 4 hours for it to cure, depending on temperature and humidity.
It looks like it feels like a soft marshmallow.
Yeah, it does, doesn't it? Yeah, and as Mitch mentioned, some of the big issues with it isn't getting it installed right or anything. It's keeping it from getting ruined when the drywall is going up. So it's tough. We should just use marshmallows for that in the future, huh? So as well as the on-site testing and inspections, the HERS rater also will fill out the appropriate checklists and then handle the energy modeling and the certification of the home. So timing. When do you want to contact your HERS rater if you want an Energy Star? At final, of course. No, but it happens sometimes. Someone will say, hey, I want my house to be Energy Star. And the first question I always ask is, where are you at in the construction process? And if they say, we just got C of O 2 weeks ago, then I say, well, I'm sorry, your home will not be Energy Star. That's just how it is. Ideally, we'd love to be in there and when you're drawing up plans, so that we can show you the things that are specifically required for Energy Star, and things that's just going to make your life easier. So plan stage is great. If you've poured a foundation, yeah, we can still help you, even into framing. But really, you get to a certain point, and we just can't do anything for you. So the sooner the better. And then we'll just tell you if you've gone too far and you don't get to be Energy Star. So barriers to certification. So I just put up two things. There are literally hundreds of lines of checklists for Energy Star. But it feels to me like the two things that seem to cause people the most trouble is the duct leakage and getting the ventilation fans right, because Energy Star requires a ventilation fan that can and usually is on when the switch is off. It's on at a lower level, so it has to be wired differently. You've got to run a constant hot to a ventilation fan, and then a switched line to that. And once sheetrock is up, running an additional run of Romex to another room is really difficult. People usually aren't willing to do it. So getting in there and getting all your wiring done and ducting done correctly, so that you can you have to have ventilation to the outside from the kitchen for Energy Star. And there's a variety of strategies you can do that, but for all of them, of course, you've got to have a duct to the outside from the kitchen area, whether that's a range hood, a microwave, or a dedicated ventilation fan. And in some cases, that's challenging. So that's another reason it's best to know the specifications at plan stage, and to be able to plan for these things. It makes everything so much easier. And the duct leakage. I mentioned that it's code if they're in unconditioned space. I may have also mentioned that not every city in Utah enforces that code. And so in a lot of cases, HVAC contractors are not used to having their duct systems tested for leakage. And so that can be a challenge for some up front. Just a hand to stretch. Okay.
Can I add one?
Yes.
For multifamily projects, air sealing the envelope as well.
Oh, yeah. So Mitch just mentioned that specifically for multifamily projects, air sealing the envelope. And it has to do with the party walls, but it is far easier to get a single-family detached home on a basement to reach 3 air changes per hour than it is to get a multifamily unit to hit 6 air changes per hour, I think. They're just inherently more difficult. So if we're talking about Energy Star in a multifamily scenario, yeah, the envelope infiltration is a big deal there. Okay. Now, this is from a HERS rater perspective, and I know that everything costs money. But when I work with builders and we are trying to figure out solutions to reaching Energy Star, they're saving money and hitting your head against a brick wall for 20 minutes, or maybe spending a little bit more money and doing something that's going to it's going to definitely save you time and headache. If you use all sealed combustion appliances in your home, if you're using gas or electric, okay, that is going to, you're going to eliminate your combustion duct, which is going to tighten your home up some. It's also going to remove the requirement of having an air-sealed mechanical room. And a mechanical room might be the most difficult room in a house to try and air seal, because it's oftentimes near an electrical panel, and you've got plumbing runs, and you've got ducts running in and out of it, just because you've got your water heater and your furnace. You've got water lines and duct work, and typically Romex running in and out of that room. So it's really hard to seal up. Put in all sealed combustion appliances, and that goes away. You don't have to build a mechanical room around it.
That's a code requirement too.
Yeah. Oh.
That room has to be sealed.
That room has to be sealed off, code requirement.
Curious if that ever gets enforced.
Yeah.
Occasionally.
But it's not truly air sealed. You're gonna look at it as a door on it.
Exactly. Just an exterior door.
Yeah.
Doesn't matter if it's leaky.
I've seen some where they, I probably have pictures of it somewhere, because it just cracked me up and made me cry at the same time, where they all they had was insulation between the studs. There wasn't drywall, there wasn't OSB, it wasn't even faced. They weren't even faced bats. It was just pressure fit fiberglass. A stiff breeze would have knocked that room over. Anyway. Blown in insulation. I asked if we ever see insulation installed correctly. The only time I've ever seen bats done really well is by the homeowner themselves, because the homeowner isn't being paid by the piece. Insulation contractors are typically not paid by the hour, they're paid by the job. So they are incented to get in and get the job done as quickly as possible and move on to the next one. And so that typically means that if the choice is to neatly cut the bat around the switch box or just kind of shove the bat in around it, they're going to shove the bat in around it because it takes 1 second versus cutting it out. It might take 30 seconds. It's just the nature of the business. And blown in insulation in a 2x6 wall will typically take you from R19 to R23, which is good. But I think the greater value is the quality of the install is inherently much, much better in a blown-in product. Now, I know that when I say that, I'm spending other people's money. I'm fully aware of that. But I also think that the product that you get is far, far better. This is just my opinion, and Mitch might disagree with me on this. I like just if you're going to build Energy Star, you can using a range hood vented to the outside for your kitchen ventilation. Again, your other options are typically using a venting your microwave to the outside, or actually just installing a ventilation fan some other place in the kitchen. But with a range hood, you've got an opportunity to capture the pollutants at the source. And so it's just going to do a better job of getting the smells and things vented to the outside. You've got the benefit of proximity on your side if you're using a range hood. So if you're planning that from the get-go, I think it's a good idea.
Also required by code but not enforced.
Also required by code, but not enforced.
Old code and mechanical code.
Oh, mechanical code. Okay, yeah.
Only if it's combustion.
Oh, okay.
Yeah, in the code, it's only if it's combustion, only if it's gas.
No, kitchens are required to have ventilation fan.
In the mechanical code. Okay. So mechanical code requires kitchen ventilation. Energy code, yeah. My last point on here says, partner with a good HVAC contractor. Hint, if he or she is rolling their eyes as you explain requirements, trouble lies ahead. I sat in this has been years ago, sat in a training once. A different HERS rater was given a training to a large production builder about the requirements of Energy Star. I think they were going to start building in Daybreak at the time, and it was required there. And so they were just informing their supers of what was required. And at the back of the room were their two construction supervisors who all the supers reported to. And those two guys stood with their arms folded, rolling their eyes, rolling their heads, leaning over and whispering, going like this to each other. And I'm like, I know this builder's going to fail miserably because the guys who are in charge of construction for this builder, they don't believe in this stuff. They think it's stupid, and they don't want to do it. And that's typically a really big red flag. So, and a lot of Energy Star certification really is dependent on your HVAC system. Certification falls disproportionately on HVAC contractors and insulation contractors getting it done right. So if your HVAC contractor is, first of all, open-minded and believes that their systems could be improved possibly with I'll say duct sealing to go crazy, other things as well, then you're in a good place. But if they're resistant, you'd have a long road ahead of you. So yeah, getting someone to buy in.
Hooking a fog machine up to an HVAC contractor's duct system will get those eyes to stop rolling.
Yes, yeah. That is maybe one of the more gratifying things that a HERS rater is able to do, is to show visually how much a duct system is leaking to a recalcitrant HVAC contractor who is convinced that their ducts don't leak. Because it will. You put theatrical fog into the duct system and then pressurize it, and you can just watch it blow out of everywhere. And it's a good first step to show them that actually all the seams do need to be sealed. But getting someone who is open to doing things, and quite honestly, the Energy Star requirements are really based off of an HVAC trade group standard. It's the ACA QI5 standard is what Energy Star based their requirements on, and that's an HVAC trade group. Yeah, life is good if your HVAC contractor is easy to work with, and is trying to do their best job, and life is tough for an Energy Star builder if that's not the case.
Do you have more slides?
That's just questions.
So if you are Energy Star, what incentives do you get?
So, Energy Star, what we came here to talk here about, you got 45 Ls. You're eligible for $2,500 tax credit from the federal government. Now, I only have 4 minutes left, and there's actually one other really big thing I need to say, and I don't have a slide for it, because I think Pat mentioned $5,000, and all I'm talking about is $2,500. There is another certification out there. Energy Star is EPA, Environmental Protection Agency. DOE, Department of Energy, has another certification. It's called Zero Energy Ready. And I'm just going to keep it really quick, and then we can talk later. Zero Energy Ready is Energy Star certifications requirement, Indoor Air Plus, much easier certification than Energy Star, and a little bit more efficiency, and then preparing your roof and your house for future solar install. So you got to make sure your trusses are engineered to carry the weight of a solar system. You got to have south-facing roof. You've got to run metal conduit from the proposed location of the array down to where your inverter would be, and then conduit from inverter to your panel, and just mount a 4x4 square of wood on the wall where you could mount an inverter. So it's really prepping the house to have solar installed on it. You do have to have at least 110 square feet of south-facing roof. I say south-facing, plus or minus 45 degrees of due south, which is a huge variable. Up to 440 square feet if the house is large. You have to be in a sunny place. All of Utah qualifies. If you hit those requirements, then the 45L goes from $2,500 to $5,000. I'll be honest, we are arguably baby stepping most of our customers. I think there's a bigger jump from standard building practice to Energy Star than there is from Energy Star to Zero Energy Ready. But we're trying to get everyone here and comfortable, and then we can hopefully jump them up, and hopefully it makes sense for most people to go after that Zero Energy Ready. But that's exciting stuff. In the past, there hasn't been really much financial incentive for doing the Energy Star certification specifically, and now there is. And I know we're just about out of time. If you're building homes to Energy Star, it's not just the federal tax credit. There are rebates available from local utilities, Rocky Mountain Power, Dominion Energy. Now, their rebate is not specifically tied to Energy Star certification, but if your homes are efficient enough to be Energy Star certified, I know that there are rebates available for them. This is what we do. So, it could be as much as another $1,800.
Can I add a caveat?
Yeah.
If you're a manufacturing company, there's also even more credits or rebates from Dominion as well.
Okay.
Specifically.
Okay. So,
And that doesn't have to be energy efficient, just if you're a manufacturing company in general, there are rebates you get from energy companies.
okay.
In the state of Utah.
Yeah, I think it's a good idea to, and we, we're very familiar with the rebate offerings from Dominion Rocky Mountain Power with relation to new construction, but visiting thermwise.com and wattsmart.com and seeing what rebates are available, because they've got commercial rebates, agricultural rebates. There's broad suites of rebates available, and always good to know what those are. So, yeah.
Troy?
Yeah.
How much does this cost?
Yeah, You know, that's a great question, and man, it depends because you know we've got some builders that they were pretty darn close already. They were already using sealed combustion appliances, and they were doing blown-in insulation, and they were air sealing their homes really well, and were using ASHRAE fans, and it's really about kind of crossing T's and dotting I's for them. But others, it could be close to a wash.
How much does it cost to get certified? Like, how much? What's the
How
going
m-
rate?
Oh, for a Raider?
400 to 600?
Yeah, $400 to $600.
Does the size of the home matter?
Really what?
How many homes?
And how many are you gonna do? Okay.
Yeah, and I will say, I would care more about how many HVAC systems there are. Obviously, that changes with the size of the home, but you know, if you got a 1,700 square foot home with one system or a 3,500 square foot home with one system, that probably wouldn't be much of a difference. But if we're talking 4 HVAC systems, obviously that's a lot more work. So.
I'd like to mention one more benefit to being Energy Star certified for multifamily homes. And that's that when you're Energy Star certified on a multifamily project, you are eligible for a HUD product called the HUD 223F. And with that product, you have to pay a little less than half the normal amount of mortgage insurance. And so in addition to getting $2,500 to $5,000 per apartment unit, you also save $300 to like $600 every year on that apartment unit, if you're Energy Star.
Do you have to test every unit? Say it's a 360 unit multifamily.
We have to inspect every unit. We don't necessarily get our duct tester on it.
Okay.
We can
Yeah.
do some.
There are provisions in the Energy Star that allows you to, it's called sampling, to, yeah, so. We did it.
Thank you, everybody, for coming today. I would like to give a special thanks to Mitch, Troy, and Pat for being able to present today. Thank you for all of you for coming and sitting with us. Thank you, Department of Energy, Utah Office of Energy Development, Rocky Mountain Power, and Dominion Energy for sponsoring these events. We do have, our next event will be coming in March regarding the IECC 2021 Commercial Code. April, hopefully, we're crossing fingers that we have answers on the residential at that time, and we will be doing a class in April for the residential IEC 2021.
It'll be called 2021.
It'll be called 21 regardless of what we do with it. Okay.
Yes.
But so those events are coming up. So please be aware. February, please check out our newsletter that will be going out. We have our website and our blogs that we also have on our website. If you're interested in finding more information, please check out there. Thank you again.